Hello guys, today I will tell you how you can calculate your solar panel system for your house from small to medium setup. So in this Excel sheet and in this lecture I will explain all the basic concepts and some advanced concepts that how you can calculate your solar panels and some correction after results. I will explain each and everything step by step, and then the battery capacity, how we can calculate, then the inverter capacity, then the battery corrections after all these calculations, and similarly our load in summer and winter. So follow this lecture step by step, and at the end of this lecture I hope you will learn a lot of things. So first of all, we need to understand what is our load, household load. The one procedure can be, you can do a traditional method, like you can calculate your load like fridge, freezer, lights, their power rating, backup power, blah blah, and all these manual calculations. But the method that I would prefer is to use your electricity bill of 1 year and then calculate your units or kilowatt hour that you consumed each month. For example, in winter I consumed in January 83, in February 75, blah blah blah, and then in summer starting from May I used 177 till September, and then in October 191, and November and December. And then I have highlighted this the peak value of my 1 year. This is the peak units that I consumed in 1 month. And then we have to decide the timings. For example, fascia 1, phase 1, phase 2, and phase 3. This is not the electricity phase, this is the phase of hours. For example, my electricity company is providing me the values of hours. For example, from morning 8 o'clock till evening 7 o'clock, I consumed these units with respect to months. So in month of September, which is having my highest unit consumption, I consumed from 8 to 90 units. And then the phase 2, fascia 2, that is evening hours, like from 7 of evening till 11 of evening, and in the morning 7 to 8. And similarly phase 3, that is from uh, from 12 o'clock in the night till 7 in the morning. So these two phases, F2 and F3, will help me uh, to size my battery, and this F1 will help me to size my solar system. So for example, if you I show you my electricity bill. If you go here, you can see they give me this one, phase 1, phase 2, phase 3, fascia 1, 1, 2, 3, total power in April 2023, and then the whole year 2024, 2025, it depends. So I will take all these values, and I will know that which is my uh, consumptions with respect to each month. Then this 243 is the consumption of September. It means 30 days. Then I have to divide this value with 30. Okay, and then I will get my 8 units per day. And out of these 8 units, I am consuming 3 units for F1, that is from 8 in the morning till 7 in the evening, that is when there is a sunlight, and then 2.13 units when there is evening, and 2.9 when there is night. So this is my values. And similarly, to convert from kilowatt hour in watt hour, just for my simplicity, I just multiply these value with 1000. So these are my values. I have to consider this value 3000 for my solar system, and these two values for my battery capacity. One thing I would like to mention that uh, if you see my whole year, this is the maximum capacity. So I would prefer to calculate the highest capacity so that even in winters and even in summer, I don't have to do much changes. In winter, okay, I will get some more power, but in worst case scenario, I would like to have my system designed on the highest value of the year. Now, the first step is to calculate our solar system, solar panel, that what capacity exactly I need, cumulative capacity to run my appliances. Till now, we have finalized our load. So, taking this value, this is my maximum load. So, 3000, that is in watt total. But keep in mind that this is the 3000 value is the exact after all losses that I am needing. So considering 40% of losses, as you know, there is no any solar panel that is 100% efficient. For example, if I am taking a solar panel of 500 watt, it will give me 400 peak value when there is perfect sunlight and normally 350 watts. So there is almost 40% losses, keeping in mind cloudy days, less sunshine hours, blah blah. And then calculating this value, I will get 5000. 5000 is the overall solar panels that I will be needing, which will give me 3000 of power that will run my appliances. So this one and this one. So as I told you before that F1 will help me to calculate my solar panels, but F2 and F3 that are the night timings from night 7 till 7 a.m. So this is my battery capacity values. So I will add these two values and I will know that what would be my energy consumption at night. So this is 5100 watt hour that I am needing on average during night. But as you know, there are some losses in the battery. So this value is after all losses. So I have to calculate the losses and then I will get the exact value of the battery that I will be needing. So I am assuming 15% losses, that is 0.85, and then there is discharge, uh, depth of discharge, that is 80%. This means that our batteries should not drain 100%. For example, if my battery is 100% fully charged, then when it goes to 20%, then it should not drain anymore, just to prevent the life of the battery. So depth of discharge is roughly 90%, but I have put it on 80%, that is zero point 0.8. Then I will be using 24 voltage system because normally 12 voltage system we will use for very small setup, but 24 voltage for medium size houses. So I will connect two batteries in series, 12 volt to get the 24 volts. So this is 24 volt batteries. And then autonomy 1, that how many hours you need autonomy, keep it 1, no problem. Okay, so this is 312 ampere hour. This is the size of the battery that I will be needing to get this energy. So this is our battery capacity that we will be needing. After calculating the size of the battery, this is my size of the battery, then I have to see in how much time my battery will be charged based on these solar panels. So assuming 6 hours, like 6 hours of sunlight to charge this battery, I will be getting uh, 52 amperes. So I will be needing 52 amperes per hour from my solar panels on average to charge my this battery in 6 hours, because I am assuming there is 6 hours of sunlight, but in my region it is even more. In winters it is like 8 hours, 6 to 8 hours, but in summer it is like 12 hours, and in some cases there is even 15 hours, so no problem, but I am assuming just a low case scenario. So 6 hours, or we have to see how much in the energy capacity. This is the ampere hour, but if we see in the watt hour, I just divide my watt energy divide by 6 to get the watt hour that I will be needing from my panels. So it means the watt hour that I have calculated here, I needed this watt hour more to add in this so that I can charge my batteries within 6 hours. Okay, but we have to again put some losses, 40% of losses, and then I get around 1500 watts that I will be needed apart from 5000, because this 5000 will run only, just let me show you, this 5000 will run only this power. I will be needing this energy to charge my battery, so I have to add this one with this one. So now we have put this extra energy, extra watts that we will be needing for batteries, and we have summation of both these values, that is 6500 watts I will be needing total to get my 3000 watt for the appliances during daytime, and the rest will go to charge my batteries. For this one I have put a note that these 3000 watts are for almost 8 hours, from 8 in the morning till 6 7 in the evening. So in this case scenario I will be getting like 500 watts per hour, but that's 500 watt per hour is not correct value, because this is the lowest on average value. What if I run, for example, two fridges, one TV, and one air conditioner at the same time? My energy will be like 2000 watts. So that is the reason I will be taking the maximum watt. The next step is to size our inverter, but please, I will tell you that these values are still not 100% okay. I will show you how. I will do some more calculations and then we will find the exact values. This is just a rough idea. Now we will size our inverter. So I will take the value that I have just calculated. We have 6000 watt, then we have to take the losses of 20%, so I have to divide by zero point 0.8 to get the losses, so it's 8, roughly 8 kilowatt of system. So I need the inverter of around 8 kilowatt or 8.5 or even 9 kilowatt. So guys, after calculating my solar panels, battery capacity and inverter values, it's time to check our system. But these are the correct. Let me delete this one. I will explain it later on how I have calculated it, just not to mix everything. So the part is to check our system. So power available is 3000. Keep in mind this 3000 is after installing 5000 of solar panels on my roof. That will provide me 3000 watts. I will run stove or AC. So I have write one point to manage between loads. If stove of 1400 watt is running, electric stove, then the AC of 1200 watt should not run. Similarly, if washing machine is running, no AC, stove, iron should run. So I have to make all these four scenarios. So even stove will run or even AC will run of 1400. Fridge and freezer will run every time it's 600 watt. Lights roughly 50 watts because I don't have so much mm, high wattage lights. TV is 200 watts, and still this 200 watt is not all the time turn on, but like 6 to 7 hours per per day. So total is 2200 watts, and I have a surplus of 750 watts that will be used to charge these batteries. So I can have some compensation on this part, that I will be needing extra panels of 850. I can have compensation. But again, keep in mind that I will not run stove or AC every hour. Maybe it will run even for 8 hours out of 24 hours. So still the rest of maybe 2-3 hours they will help to charge the batteries. So after checking the capacity of daytime, now I will go to the night time that I have decided the battery. So I have calculated the battery of like 300 something. Mm, yeah, 312. But standard size battery is 360 ampere hour. Okay. Then my fridge and freezer, as I told you, will run 24 hours. I have two different, by the way. Fridge is different and freezer is different at my home. So they both combine 600 watts divided by 24 volts. This 24 volts is from the battery voltage, not 220 voltage from the electricity supplier. So we will get 25 ampere, and then AC, that is 1200 watt divided by 24. I will be requiring 50 ampere, and for TV I will be requiring 8 ampere. Then autonomy. Fridge and freezers autonomy only at night, because during daytime I have already calculated here. So I need autonomy of 8 hours. Okay. And then by multiplying 8 with the ampere, this is 200 amperes I will be needing. Keeping in mind my battery capacity is 360 ampere. Then for AC I will be turning it on for 4 hours at night, and then by multiplying 50 with 4 I will be getting 200 ampere here as well. And for TV, 4 hours during night, for example from 20 till no sorry from 8 8 p.m. to 10-12 p.m., and I will be getting 33 amperes. The point is, what would be the remaining capacity after this mandatory load? 360 minus 200 will be 160 ampere here, 160 ampere hour remaining. And then when I would turn AC on, 160 minus 200, this one, I will be shortage of minus 40. And when I turn TV on, it will be again shortage of minus 40. So roughly minus 80 ampere hour I am shortage of this battery. That is the reason I have filled all these columns after correction. So my result is divided into two parts. Daytime, okay, installed capacity of 5000 watt will meet maximum needs. Okay, but during night time I will be running short of 80 ampere hour. So I will be needing 360 plus 80, that is 440 ampere hour. Now let's recalculate our solar system as solar panels and battery system. So corrections after results that I just discussed before. Okay, before going into correction in the results, I have to do the battery corrections. Okay, what I have decided before was I would be needing 440 ampere hour of battery. So this is the ampere hour, and I have to calculate the watt hour. So I use the reverse formula that I used here. So 1 of autonomy 24 volts, zero point 0.8, same factors, and I will be getting 7000 watt hours. Here I divide, here I multiply to get this value. So For 6 hours I have divided this value. I will be needing 74 ampere per hour to charge this battery for 6 hours continuously. Or to use this value, I divide this by 6 to get 1200 watt per panel. But again, we have to consider the 40% losses, and then we have gotten 2000 watts. So we have to add 2000 watt here in our system. Let me show you in this system to accumulate this new battery size. So this is the extra wattage. Now come to this point. This is the 5000 that would be needed plus this value, and we are getting 6994 value, total value. I mean 7000 of panels I would be needing to charge this battery. Now we will not take consider this value because this is for the old values and this is for the new value. So before it was 6500, now it is 7000 watt system. Again we have to correct our inverter as well. So 7000 watt, add losses, and our system is 8.5 or 9 kilowatt, or more safely uh, 9 kilowatt system. So this is the overall scenario for all these things, but according to my point of view, this system is little bit overvalued, because as I told you, I will not run all these things for 24 hours. I will turn, for example, stove or AC, maybe both are off, maybe TV is not running, maybe, I mean, there will be plus and minus of all these values. So according to my point of view, what I have wrote is this final thoughts, that minimum solar power I can install is of 3000 by installing 5000 watt capacity. There is a difference. And similarly, I can install a maximum solar power of 7000 watt by installing 12,000 watt of considering losses. Similarly, minimum battery range is 440 and maximum is 520. This value is not so fast and hard. You can uh, make it up and down based on your needs. Similarly, minimum and maximum inverter based on the batteries and the load. If your load is 3 kilowatt, and also you have to consider the batteries, because the inverter will charge the batteries and also will provide the load and also will take the input from the solar panels. So you have to consider all these factors. In modern inverters, there is already installed the battery charge controller. Let me write battery charge controller in the modern setups. But if they don't provide, then you have to calculate the battery charge controller value based on short circuit current of the solar panels. So you have to calculate this value as well. So this is my overall idea. So this is my overall idea. I have made some calculations on winter side as well, exactly keeping in mind these values, but these values are very lower than the that I have calculated in summer. So maybe it's 50% less than the summer values. So you can design your system based on these basic things. Obviously you can do your work and improve this Excel sheet or improve this method. The purpose of this lecture is just to give you an overview, a highlight of the basic concepts. There is nothing right or wrong in this work. Thank you so much.